I'm starting to assemble the pistons on the 360 engine. So here's kind of the layout that I have. I have the oil control ring. That's what that is. And then it takes two of these little steels that make up the oil control ring, the second ring, and then the top ring. I put them in that order because it you start from the top, lay down that one, then you put that one in and that one in. If you did the top ring first, then the second ring and all the other rings have to go around that ring to get down there. So I just got my rod bearings laid out. I got a good oily rag, so I'll just do a quick wipe down, and it's actually about time I changed that one out. It's starting to get a little dirty. Rags are cheap, engines aren't. So I'll get that swapped out. Then I just wipe everything down, wipe down the skirts of the pistons, all the rings. I'll wipe those down before I install them. One of the other things I have is I'm going with the driven grease because it's more of a grease. The Lucas engine braking that I had was more of a gear oil, and it might be a little bit before I actually get this one going. So I use a little toothpick to dig out some grease and put it in these gaps on the wrist pins and lube those up real good. So I already got number one piston in. One of the techniques I use is like what I'm doing here is I put the oil control ring on first, and that keeps the piston from sliding down into the hole, and then I use the block to hold the piston while I use the ring expander to put the rings in. So one of the other things when you're putting these together, obviously the rod cap won't be on. Put a couple pieces of some fuel line can go on the rod bolts, so whenever you slide that down into the cylinder, you're not dragging the rod bolt and hitting your crank or hitting the cylinder walls with it. Showing how to install, or how I'm installing these pistons. I'm using the little compressible ring compressor here. A lot of people don't like these because, well, frankly, they're kind of hard to use. They're finicky. So one of the key things that I have here is the piston is up out of the deck pretty good. The rings aren't just resting right on the deck. This has to be good and flush with the block. If there's any gap in there, that little thin steel oil ring can pop out in between there. If you come down and try to knock this thing down in one hit, then it'll fold that ring up between the piston and the cylinder wall. Then you get to redo it with a scratched cylinder wall and bent ring. So the other thing, if you notice, I have the block not setting up square, and that's so whenever I come over here and the piston's coming in to the crankshaft, I can actually get up underneath or get to the side and put my rod cap on. Otherwise I have to be trying to do that up underneath the engine. The other thing, once the piston kind of gets knocked down a little bit and you get all the rings landed in, I like to come and double check the rod bearing to make sure the shock of putting it in didn't knock it out of place. That happens about half the time whenever I knock these in there. If I do a good hard hit, it can knock that out of place. So I'm assembling the engine. I got all my pistons and rods in, torqued all the rod bolts down, and I'm working on if I want to use this windage tray or not. And I'm not going to use it because if I use the deep oil pan, its pickup hits the windage tray. So that kind of answers that question I was trying to figure out while I'm mocking everything up. Standard engines, you don't have to do any of this. But I had these hot rod parts laying around. I want to use as many as possible. But these, I could probably go in and modify that, but I really don't want to. So that's a good thing to know there. Also with that oil pan, if it has half decent baffles, I might not need the windage tray anyway. It's going to be overkill for what I'm building. So I got this camshaft. This is the Mopar purple shaft cam, the 508 series. So it's like a 248 at 50, 508 lift. So I've cleaned this up, and this is what I'm going to put in the 360 I'm building. I actually have ran this cam before, so I've just come back and cleaned it with Purple Power, brake cleaned it out, and then I've come back and put a very light coat of oil on it to keep it from flash rusting. And then since I'm about to install it, I'm going to use the driven engine assembly grease to coat everything on this cam and stick it in the engine. So once I get that done and get it stuck into the engine, I'm going to go through the cam timing sequence of getting the cam time right, make sure I find top dead center on the engine on number 1 there, and get the cam timed in and degree it in to where I want it. Depends on what keys I have. I'll probably do 4 degrees advanced from base timing on there, and that'll help build cylinder pressure. So I'm working on degreeing the camshaft. The first step of degreeing the camshaft is finding piston true top dead center. And what that means is when your piston comes up, the highest point is not top dead center because you have a dwell time. There's a whole theory into dwell time, if you want to look into that, about different rod ratios to stroke ratios. I'm not going to get into that, but what I do want to find is true top dead center. And what I have is my dial indicator zeroed out. I have my timing pointer zeroed out as well. And I've also kind of double checked the harmonic damper, which needs to be cleaned up. It is marked and it's set to 0 as well. And I've already got my distributor in and kind of pointing up where the number 1 is firing right now at 0. Little mark I have there is where I already kind of preset it to around 12, the ignition timing just as a baseline. And I'm going to see if that changes after I degree the camshaft in and get the piston at top dead center. So I have my point A and point B marked. And what that is, once I set it to 0, going by Hughes Engine's instructions, I went 60 below on my dial indicator from the 0 mark that I had before. And I put my piece of tape on there and marked A, and then I marked what degree it read. And then I come back to the other way counterclockwise and did the same thing to get the 60 to below, and that ended up being my B point of 14. So my true top dead center is actually, since I know it's on the right hand side over there on B, it's more shifted that way. It's shifted 2 degrees. So my true top dead center would be the second mark on my degree wheel. I've done the math on degreeing the camshaft in. It comes out that it's a 111.5 center line. The center line, if I didn't have any kind of offset or advance or retard, would be at 108. So the key I put in there is about a 4 degree key. So I have that turned backwards for the retarded the cam as this numbers come out. So these little keys are called Woodruff keys, and these have a little offset built into them. As you can see, the little shelf in there. That's not standard on a Woodruff key. This is something that the small block Mopar uses to advance and retard the camshaft. You can also use a good quality timing gear set that has the offsets in there. So on these keys, the one that I have in there, I wasn't going to reuse. I just put it in there just for checking purposes. You can see this one's been used, looks like once or twice. It has some dings and nicks in it where the sprocket went on there. So I'll be replacing the key that I have in that camshaft. Like I said, I just used it for setup purposes with one of these other offset keys. And then I'll redegree it and see what I end up with. Alright, I'm done degreeing the cam in. So I got it advanced slightly. It's supposed to be a 108 installed center line. I advanced about 3 degrees is what it come out with the cam keys I have on hand. So that's installed at a 105 now. So that'll help build that cylinder pressure. So this is kind of the setup. One of the things I want to note is when you do this, the dial indicator, I got too much glare here. The dial indicator has to be in line and very steady with the lifter. If you have any variance with where the magnetic base is hooked up. If your rod's loose, if any of these connections are loose in here, whenever this lifts up and goes back down, it's going to have too much tolerance in there and you can't get an accurate reading on it. Same thing, make sure the pointer's good and stable.